Hello, welcome to Edexcel demola, and today we're going to be covering acids and bases. Really important topic because it's going to lead into titrations, which we'll cover in the next chemistry video. But for now, let's get straight into it. Okay, so we're going to kick this off with our Bronsted-Lowry acids. Now, don't stress too much about Bronsted-Lowry, not really relevant, it's just the name of some scientists. So, we're just going to upgrade what our definition of an acid is, yeah? In GCSE, I'm sure you've probably heard, has a pH less than 7, shows up as like your red, yellow, orange colors on the universal indicator, and releases H plus ions in solution. Now, what we're going to switch it up to is we're just going to say, yes, they have a pH lower than 7, but our main definition of an acid is going to be a proton donor. Cool. Proton being a H plus ion, yeah? So a proton donor. That's what we want to refer to acids as. And these acids can be strong or weak, right? Another thing that you should be familiar with from GCSE. Strong acids fully dissociate in solution, they release all of their H plus ions, whilst weak acids partially dissociate in solution, releasing some H plus ions. Cool. For this table would be useful in terms of knowing strong acids and weak acids. So strong acids, you should know these: hydrochloric, sulfuric, nitric, phosphoric acid, yeah? Whilst your weak acids are going to be your carboxylic acids. We'll talk more about them when we get to topic 4. But another one that I think is good to mention is carbonic acid, which is H2CO3. I forgot to put that in brackets, but that is fine. Cool. Now, I just wanted to show an example of dissociation. So in dissociation, what you're going to see is you have your acid, it's going to split off into its ions. So that's kind of what dissociation is, splitting into ions. And you've got a H plus ion and a Cl minus. That's 100%. And you can see it because we've shown it with this arrow here, if I highlight it. So that shows a 100% dissociation, yeah? Whereas when we have this carboxylic acid, methanoic acid to be precise, it's partial dissociation, and we're going to represent that with a reversible sign. Cool. Last thing I really wanted to mention was monobasic, dibasic, tribasic. You need to learn how to define these terms. So a tribasic acid donates 3H+, a dibasic 2H+, a monobasic 1H+. Just know those definitions will come in quite handy. Let's move on to the next part. Okay, now we're just going to do the same video but with bases, right? So, Bronsted-Lowry bases. What you would have heard before is in GCSE, they tend to talk about alkalis more. And what you would have been told about that is pH is greater than 7, there tends to be blue, purple colors on the universal indicator, and that they release OH minus ions. We're going to change that, right? So when you talk about bases, I want you to define them as proton acceptors, yeah? We've also got your strong bases and your weak bases. So pretty much the same with the acids, but instead we're now going to talk about OH minus ions. So strong releases all the OH minus, weak releases some of the OH minus, yeah? And again, we've got examples. So you got your strong bases, sodium hydroxide, potassium hydroxide, calcium hydroxide. Whereas these weak bases here are going to be ammonia. It's going to be this one. Don't stress too much about this now, but it's called ethylamine, yeah? You'll learn that in year 13. Cool. So dissociation, again, quite similar. I actually haven't drawn that, right? So we're just going to quickly rub this out. This one should still have your reversible sign to show it's a weak base, yeah? Cool. The reason why we've actually shown ammonia with water is because ammonia in itself as a compound does not have OH minus, yeah? It doesn't have it on its own. But if it's an aqueous, that just means it's dissolved in water. So essentially, you can kind of represent it as reacting with water in a way. And then that will form your ammonium, your NH4+, and also it's going to release that OH minus. So just be aware of things like that. Now, a really, really important distinction that we need to make to get our marks, yeah? An alkali is a water-soluble base. Cool. So water-soluble base, it releases OH minus. You need to remember that all alkalis are bases, but not all bases are alkalis, yeah? Really, really important distinction because, for example, metal carbonates like Na2CO3 or, for example, NaO, a metal oxide, both of these, so I'll just get that done right, both of these are bases as well, but they themselves will not have OH minus ions, yeah? So just know the difference between an alkali, for example, NaOH, and bases, yeah? Hope you're happy with that. Okay, let's talk about neutralization reactions. So, here's your typical one. Acid plus base goes to salt plus water. And I've highlighted underneath just what an ionic equation of that would be. Forget about the X. Literally just H plus OH minus goes to H2O. Yeah? And I put an example as well. HCl plus NaOH goes to NaCl plus H2O. That's your classic acid plus base reaction. Now, the reason that we kind of wanted to talk about this is because I want you to be able to name salts well. Yeah? So the first bit of the salt's name, the first word, comes from the metal of the base, whereas the second one comes from the acid. So for example, hydrochloric acid, you get a chloride. Nitric acid, you get a nitrate. Sulfuric acid, you get a sulfate. You kind of just need to work off what the acid is to get the name of the word, yeah? So you'll come across all the different examples throughout the course. Just be aware of what they are now. Cool. Now, what I also wanted to show you is this. We've got some reactions here. So nitric acid plus potassium hydroxide, phosphoric acid plus calcium hydroxide, and methanoic acid plus magnesium hydroxide. I want you to name the resultant salts. Don't worry about the equation, just name the salt that's going to be formed. So I'm going to pause for 5 seconds, allow you to pause the video, have a think about it, get your answers, and then we will have a look. Okay, so if I remove this now, oh, that's the wrong thing. If we remove this now, you'll see potassium nitrate, calcium phosphate, magnesium methanoate. So as you can see, if we do some highlighting here, you can see that you look at the metal that's here, that gives you the metal that's here. If we change to a different color, nitrate, or nitric acid, nitrate, phosphoric acid, phosphate, methanoic acid, methanoate, yeah? Just be aware of those kind of things. And then when you see your other reactions, I'm sorry that the highlighting on that wasn't the neatest, to be fair. But when you look at your other reactions, acid and alkali, salt plus water, acid and carbonate, salt plus water plus carbon dioxide, and acid plus metal oxide is going to be salt plus water. Remember all of those because it's crucial that you know the different equations that you're going to get for different acid plus base reactions. So these are just different examples of bases that you need to be aware of. Cool. Okay, and now it's time for the questions. So we'll zoom in. This is the first question. Have a read of that. Have a go. You're just explaining some terms. And then the second part of the question is this one. So a bit more complex, a bit more to do. We are going to zoom out and give you a couple of minutes to do that. Okay, and let's get into the answers now. So, guys, recall, you should be able to get this. Base, proton acceptor. See here, it says that it will just accept, saying proton acceptor. Yeah? And then alkali, you need to mention about OH minus ions very specifically. Yeah? Remember those, that's easy marks to pick up. Now, the reaction that they gave us was with a metal and acid. So you need to remember, metal plus acid is going to be salt plus hydrogen. Yeah. And then the second part of the question, you just need to be able to give us the formula. I feel like we've covered this in a different lesson, but you can know here, you should already know that sulfate, base of memory, is SO42 minus. Cerium, you can see here, and we're going to get into this when we go into redox. You can see here, it's told us that it's 3 plus. Yeah. So if it's told us it's 3 plus, we have Ce 3 plus. Remember how we swap the charges. So we swap it around. So that's going to give us Ce2 and then SO4 3 times. Cool. Now, electrons transferred again. Cerium is an atom. It's not an atom. It's a metal. Yeah, it's a metal. And we know that metals are going to lose electrons. Yeah, because it forms positive ions. So they lose electrons. Now, finally, I didn't mention this in the lesson, but this is such an important point, yeah? Whenever we're forming a salt, it's because the hydrogen ion is replaced by a metal ion. Stick to that definition. I promise you will get the mark every single time they ask about how salts form, yeah? A hydrogen ion of an atom is replaced by a metal ion. So I hope running through those answers real quick has helped you to understand. If you need to rewind, just go for that. Ask any questions in the comments below. Okay, and that wraps up this video. A bit of a shorter one today, but ACR tips. Guys, just remember the different type of acids and the ions that they release, yeah? So it's very important that you remember about the ions that we have in each of the acids, and you just remember the formula of the acids as well. Also about that, ammonia is a base, yeah? But it doesn't have OH minus. Again, just remember, it's easy to get a bit late in the course and then think ammonia is an acid. It is a base. Now, strength of an acid is about how it dissociates, not about its concentration. We could have an extremely high concentration of something like methanoic acid, doesn't change the fact that it's a weak acid. You still draw that equation with the reversible reaction arrow, yeah? the strength of an acid is determined by how it dissociates. Cool. What else do we have here? Use the reversible sign, yeah? Really important. I think maybe even a bit easy to forget sometimes, but they do tend to pick it up and deduct marks if you don't use that, if you're talking about a weak acid or weak base. And also just know the neutralization reaction. So like with the carbonates, the metal oxides, or the alkalis. Now, what should we not do? Cool. Guys, whenever they have a question in the exam, a lot of the time they're going to ask you to balance an equation as well. They might not tell you to balance it. They might just say, write a fully balanced equation. Remember, do the fully balanced equation, yeah? So it's all good remembering what the products are going to be. You need to know how to balance it as well. Know that bases and alkalis are not the same thing. We did define this earlier. The alkali, water-soluble base, releases OH minus, whereas an actual base is more just called a base because it accepts protons, yeah? That is the kind of stage to be a base, just accept protons, whereas an alkali needs to release OH minus. And then also just don't forget about metal oxides. I think they are a bit easier to forget that they are also bases. Just remember. So I hope that lesson's been really useful for you guys. Any questions, leave them in the comments below. I'll do my best to answer it. Like, share the video, subscribe to the channel. We've also got the TikTok and the Instagram, both at demola. Next week, we are going to do titrations, which is going to be a bit more complex, but very, very important. So we'll catch you in the next one. Bye for now.